Okay, today we're going to continue our discussion about algebraic fractions, and we're going to talk about how we can multiply and divide them. So this covers AA18, which is multiply and divide algebraic fractions and express the product or quotient in simplest form. So we're going to cover all the standard today. Okay, so when we multiply fractions, it's going to be similar to a method of multiplying arithmetic fractions. So let's just recall, if I have an arithmetic fraction that's a ratio of two integers. So let's say I have 3/4 times 8 over 9. Now 3 over 4 is in simplest form, so I don't have, simplest form means that 3 and 4 do not share any factors other than 1. And 8 over 9 is also in simplest form because 8 and 9 do not share any factors other than 1. But before I multiply, I want to look at the numerators, the combination of every numerator and denominator. So 3 over 4 don't have a common factor, but 3 over 9 have a common factor. So I want to, the common factor between 3 and 9 is 3. So I want to divide 3 and 9 both by 3 in order to get, in order to cancel out terms. So another way of thinking about this is factoring. So 3 is already a prime number, but 4 can be factored into 2 times 2 times 2. And 8 can be factored into 2 times 2 times 2. And 9 can be factored into 3 times 3. So if I look at what I have for common factors, I can just cancel common factors as I see them, because the long way of doing it is, well, if I'm multiplying across, this whole thing would be 3 times 2 times 2 times 2 over 2 times 2 times 3 times 3. And multiplication is commutative, so I could put the 2's in the front in the numerator. So I'd have 2 times 2 times 3 times 3 in the numerator. And then in the denominator, I'd have 2 times 2 times, let's see, I have too many 3's in the numerator. I should only have 1 3 in the numerator. So in the denominator, I had that 9, so it would be 3 times 3. Now, and I'm also missing a 2 in the numerator, I see. So somewhere along the line, I misplaced my 2. So in the numerator before I had 8, so that's 2 times 2 times 2. In the denominator before I had 4, so that was 2 times 2. And then I had 3, which is this 3 right there. And then I had 9, which is that 9. So here I can just cancel out the factors of 2 and 2, 2 and 2. And when you cancel, you're just dividing them to get 1. And I can also cancel out a 3 and a 3. So what I have left is 2/3. Now, I know that seems like a really long process. Let's go back to the beginning for just a second, and I'll show you another step of doing this. This may be what you learned in like 4th grade here, 3/4 times 8 over 9. So we would say now in 8th grade that 3 and 9 share a factor of 3. So I would divide 3 by 3 to get 1, and I divide 9 by 3 to get 3. Okay, so really what I have left multiplying is 1 over 4 times 8 over 3, okay, because I canceled. But 4 and 8 share a factor of 4. So 4 divided by 4 is 1, and 8 divided by 4 is 2. So really what I'm doing is I'm doing 1 over 1 times 2 over 3. Well, 1 over 1 is just 1, and 1 times the number is itself, so I have 2/3 here. Okay, we're going to use a method very similar to that when multiplying algebraic fractions. So for us, what I can do is, let's look at our fraction here. We have 5, in the numerator of the first fraction, we have 5a to the third, and in the denominator I have 9bx. And then the numerator of the second one, I have 6bx over a squared. So what I can really do is, this is really just 5a to the third times 6bx over 9bx times a squared. Okay, and I can also rearrange it, because multiplication, don't actually perform the multiplication, because a lot of times it's not complicated with monomials, but it will be complicated when you get to trinomials and binomials. So I want to rearrange the a so that it's in the front, which I can do because multiplication is commutative. So in the numerator I have 5a squared times 6bx, and I have a squared times 9bx. Now I can see right away that the bx is canceled, because they share a factor of bx, and bx divided by bx would just be 1, and this would be 1. But if you'd like, you don't have to put the 1s there. Just remember that when you divide, you'd be left with that 1. Okay, so 6 and 9 share a factor of 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. Now, whoops, this was a to the third. A to the third divided by a squared just gets a. So I can divide, in other words, a to the third divided by a squared just gets me a in the numerator and 1 in the denominator. So here I can cancel this out and leave a 1 in its place, or I don't have to write the 1. And a to the third I want to cancel out to get a, to just get a. So let me just rewrite that. So what I'm really multiplying is, what I'm left with is 5a times 2 over 3. So that's just 10a over 3. Okay, and that's in simplified form. Because you simplified before you multiplied, what you get is in simplified form already. Okay, let's try another one. All right, so these are two algebraic fractions. The first one has a trinomial in the numerator, and the second one has a binomial in the denominator. So you're going to have to really think about our factoring rules. If you have a trinomial, you can use the x factor to put it into its binomial factors. The coefficient of the middle term goes in the top, and the constant goes in the bottom. And I fill it in with numbers that add to -5 and multiply to +6. So then this fraction becomes x minus 2 times x minus 3 over 3x. Okay, times, now 2 can't factor anymore, so I have 2 over, and then the denominator here is a binomial, and it's not the difference of squares, so you have to pull out the greatest common factor, which is 4, and the remaining terms are x minus 3. Okay, now what we can see here is, you don't have to rearrange it this way, but let me just show you if I rearrange the top here. The top is really just 2 times x minus 2 times x minus 3. So I went ahead and I multiplied these two numerators. And the bottom here is 3x times 4 times x minus 3. Okay, so we can see that x minus 3 is a common factor here, so we can cancel that out. And 2 and 4 share a factor of 2, so 2 cancels out to get 1, which I don't have to really write, because there's something already left in the numerator. And 4 cancels out to get 2, so I divided 2 and 4 by 2. So in the numerator I have x minus 2, and in the denominator I have 3x times 2, which is 6x. And that is as far as I can go with here. Remember, I can't cancel the x's because the x in the numerator is a minuend, and the x in the denominator is a factor. So this is as far as I can go here. Okay? All right, let's try another one. So I have 12a times 3 over 8a. Now 12a is not a fraction, so I'm going to make it into a fraction like this. So the numerator says I have 12a times 3, and the denominator says 1 times 8a is 8a. But I don't want to multiply those out. So I want to think of, well, a and a cancel immediately. And 12 and 8 share a factor of 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. So in the numerator I have 3 times 3, which is 9 over 2. And that's as far as I can go. 9 and 2 don't share a common factor. Okay, one more. So in the numerator of this one I have a monomial, and then I have a binomial, and then a binomial in the numerator and a monomial in the denominator. So if I were to multiply these, I'd actually have to put the parentheses into the numerator binomial and the binomial in the denominator. So really what the product would be 2r times r minus 1 over r minus 1 times 10. Well, you can see when you do this that r minus 1 is a common factor, so I can cancel that. So what am I left with? I'm left with 2r over 10. But here, 2 and 10 share a factor of 2. So 2 divided by 2 is 1, which I don't have to put there because r is there. And 10 divided by 2 is 5. So what I'm really left with is r over 5. Okay? Now we're going to move on to dividing algebraic fractions. And so the one change that we have when we're dividing is we're going to use a keep, change, flip method. So that's the only thing that's different between the multiplication and division. Once we're there, we're going to use the same 3 steps that we used in the previous. Remember, these 3 steps here, it's the same as these lower 3 steps after you use keep, change, flip. So the first step is to keep the first algebraic fraction, so 16c cubed over 21d squared. And I'm going to change this to multiplication, and I'm going to flip the second fraction. I'm going to reciprocate it. Now, if you want, you can actually multiply these together. So you can rearrange these fractions in order to see more easily what cancels here. So if you want to, you can rewrite them all under one numerator and denominator. So I'm going to keep 16c cubed first and 14d cubed second. And then I'm going to rearrange these two. I'll put 24c to the 4th times 21d squared here. Okay, so I don't want to multiply these out because it just becomes more complicated. I don't want to multiply 16 times 14 and 24 times 21 because then I have to figure out what the factors of that is so that I can cancel. So instead, let's just do it step by step. C cubed and c to the 4th cancel, but one c remains in the denominator. D cubed and d squared cancel, but one d remains in the numerator. So what do I have left? I have 16 times 14d over 24c times 21. Now 16 and 24 share a factor of 8. Okay, so 16 divided by 8 is 2. So divided by 8 is 2. 24 divided by 8 is 3. Okay. 14 and 21 share a factor of 7. So 14 divided by 7 is 2. 21 divided by 7 is 3. What do I have left here? I have 2 times d over 3 times c times 3. Okay, now there's no common factor, so I can go ahead and multiply these out. In the numerator, I have 4d. In the denominator, I have 9c. Okay, and that is as far as you can go with that one. There's no common factors. Okay, let's try another one. So again, the first change I make is keep the first one, change it to multiplication, and reciprocate the second one. Okay. Then we want to factor the numerator for the first algebraic fraction is not a difference of squares, so my GCF is 3y. I would have y plus 3 remaining over 18 times 27, and then 5y squared nothing cancels about that. Now remember, these are all factors. I have 3y, y plus 3, and 27 as factors in the numerator. So what I have left is 3y. I'm going to put 27 first, and then I'm going to put y plus 3 last. I'm just going to organize it like that. And then I'm going to put 5y first in the denominator and 18, and that's all I have in the denominator. So I can see easily that y and a y cancels out of y and y squared. It leaves a y right here. 18 and 27 share a factor of 9. So 27 divided by 9 is 3. 18 divided by 9 is 2. And I think that's all I can do. So what I have left is 3 times y plus 3. And then in the denominator, I have 5 times y times 2. So I have 9 times y plus 3 over 10y. And so in the numerator, I have to multiply through. I have 9y plus 27 over 10y. And there's nothing I can do. Again, I can't cancel the y in the numerator because the 27 does not have a y. Okay, so I can't cancel the numerator y right here with the denominator y because 27 does not have a y. So this is as far as I can go with this one. Okay, let's try another one. So keep, change, flip here. 4a squared minus 9 over 10. And you might want to pause the video to see if you can do this yourself too. 10a plus 15. Okay, factor. This factors into the difference of squares. 2a plus 3. And the other binomial is 2a minus 3. And that's going to be over 10. You want to multiply that by 25 over, and then 10a plus 15, we can factor out a 5 there, so we have 2a plus 3 here. Okay, now everything's being multiplied in the top and the bottom, so I can start canceling. Now 2a plus 3 is going to cancel with this 2a plus 3. And 10 and 25 share a factor of 5, so we're going to leave 2 and 5 here. So on the top, what you have is 5 times 2a minus 3 over 10 on the bottom, right? Because it's just 5 times 2. Now 5 and 10 share a factor of 5, so I can cancel this, leave a 1 here, or not leave a 1 there if I don't want to. And on the bottom, I divide 10 by 5 to get 2, so what I'm left with is just 2a minus 3 over 2. And that's it. Okay, finally we have this longer one where the first two are being multiplied and the last one is being divided. So the first thing I want to do is do a keep, change, flip, but I'm going to keep this whole one here, change this to multiplication, and flip this second one. So the first one is, and I'm going to add my parentheses in here. So I have x plus y, and the bottom is x squared plus y squared, and I'm multiplying that by x over x minus y. So there's my keep. Change this to multiplication, and I want to reciprocate this second one over x plus y squared. Okay, now I can break this down, and I'm not going to put that as an x, I'm going to put that as a dot. Okay, I can break this down. Let's see, which are the ones that can be this? There's nothing to do about this one. There's no way to factor this one or this one or this one or this one. But this one is the difference of squares, and this next one is I can write as two binomials being multiplied. So let's just go through and do that. Okay. So I have x plus y over x squared plus y squared times x over x minus y, okay? And I want to multiply that by, now this becomes, let's break this down real quick up here. X to the fourth minus y to the fourth becomes x squared minus y squared times x squared plus y squared. But this right here is the difference of squares. So this can break down into x minus y and x plus y. And then this would be brought down, that would be x squared plus y squared. Okay? So the top here would be x minus y and x plus y times x squared plus y squared. Okay? And the bottom here is x plus y times x plus y. Okay? Then let's start canceling. Well, we have an x plus y here and an x plus y here. We have another x plus y here, another x plus y here. We have an x squared plus y squared and an x squared plus y squared here. And we have an x minus y and an x minus y here. So we are left with just x. So this whole thing just cancels out to x. And that is the last example here. So just to review, if we are dividing algebraic fractions, we use keep, change, flip. And then we factor, cancel common factors, and multiply. If we are multiplying, we want to factor, cancel common factors, and multiply. Okay? And if you're having difficulty with this, this lesson, you might want to go back and seek out the lesson on factoring completely. Okay, we did that sometime in the fall because this totally, all this factoring stuff, like especially this last one right here, this last one right here, that whole factoring business we did sometime in October. So that was something that we had to learn, and it took us a while to learn that. So if you're having a difficult time, it's probably with the factoring.